So now that we've done our unit circle, there's going to be a fair number of questions that we're going to solve without our calculators. And the way that we solve them without our calculators is we have to be able to recognize values on our pie plate. So here we have sine of theta equals negative root 3 over 2. From before, we would have said, oh, I know this is negative, so it's in quadrant 3 or quadrant 4. I'd find my reference angle using my calculator and then do either, if it was degrees, 180 plus and 360 minus my reference angle. Now that it's in radians, I do that same idea with radians. But if it's something that's on our unit circle that we have memorized, so here we're looking at sine, do we ever have a y-coordinate of root 3 over 2? What family is that? Okay. Root 3 over 2 happens when we have our reference angle. That's part of our pi over 3 family. So without our calculator, we get a reference angle right away. According to our cast rule, sine is negative in quadrant 3 and quadrant 4. And the domain that we're asked for is we're asked for solving all 4 quadrants from 0 to 2 pi. So what is the pi over 3 family member in quadrant 3? 4 pi over 3, 1 more than the denominator. And what is the one in quadrant 4? 5 pi over 3, 1 less than double the denominator. And that's all the work you'd have to show. You don't have to draw your triangles. You can just say, I know it's my pi over 3 family. I know from my cast rule it's in quadrant 3 and quadrant 4. And I can just write down the answers once I get them. So again, we're going to solve each of these from 0 to 2 pi. Okay, I'm going to give you a head start on A, B, C, and D here. Cos of theta equals negative 1. Do you have negative 1 as an x-coordinate somewhere on your unit circle? Yes. That happens when theta is equal to pi. Tan theta equals negative 1. So what you can do is you can say to yourself, well, does tan ever equal to 1 or negative 1? Yes, that is part of my pi over 4 family. But it's only going to be part of my pi over 4 family when tan is negative. So I'm looking for quadrant 2, 3 pi over 4, and quadrant 4, 7 pi over 4. Secant theta equals 2. Again, if you know secant, you can write cos because it's the reciprocal. If cos of theta is equal to 1/2, do we ever have 1/2 as an x-coordinate on our unit circle? What family? Pi over 3 family. It's positive, so it'll be in quadrant 1. And quadrant 4. And this one we have to do a little bit of work. In order to get sine theta by itself, you would subtract 1 and then divide by 2. Is 1/2 ever a y-coordinate? What family? Pi over 6. We're looking for negative 1/2, so we're looking in quadrant 3 and quadrant 4. So these are straightforward trig equations when you have the number right away. We will also get trig equations where we have to factor. So whenever you had x squared and you were solving in grade 11, you learned the skills of factoring things. And so now we can have the same thing if we have sine squared or cos squared or tan squared. We're going to have to factor. So At the beginning, it might take you a little while just to factor with sine and cos. But if you thought of this same thing as x squared minus x equals 0, could you factor that? Yes. That's right. But you are aiming to get 100% tomorrow. And you should be, when you're practicing tonight, time yourself, see if you can do it in 10 minutes or so. 10 to 15 minutes. So you have to know it well to be able to do that. Okay. How would you factor something that was x squared minus x? You'd take out an x. There'd be a common factor, right? Well, we're going to do the same thing here. What's in common between a cos squared and a cos? You can factor out a cos of theta, leaving you with cos of theta minus 1 equals 0. The reason we factor, yes? So when we want to write cos times cos, which makes like x times x is x squared, when we want to write cos times cos, we write the squared in there. So this cos squared theta means cos of theta times cos of theta. And once you factor it out, well, that means either cos of theta is equal to 0 or cos of theta minus 1 is equal to 0. Now this is a step that, especially on the right, you'll probably skip this step right here and immediately say this. Does that make sense? Now I'm going to back up and review why do we factor. Why do we factor when we solve? Well, if I look at my x squared minus x equation over here, and I tell you I have two numbers in my head, and they subtract, and they equal 0. Can you guess what two numbers they are? I'll make it easy. No. Another guess. I have two numbers in my head. I subtract them, and they're equal to 0. What are the two numbers? You just have to tell me tell me just one of the numbers then. Could be 1 and 1, but it wasn't. That's not what I had in my head. Could have been 2 and 2. It could be, you could guess forever, right? And you might get it or you might not. I made it easy. I made it 8. I was tempted to use 7.2, but then I think you'd be guessing for a long time. Okay? So when we're subtracting and you're guessing and checking what would work, it's not easy, because there's a lot of numbers that subtract to equal 0. But as soon as you factor, what you are doing, and the reason it's so powerful, is you're changing subtracting from two things being subtracted to two things being multiplied. And now, if I tell you I have two numbers in my head, they multiply together and they equal 0, can you tell me one of them? One of them has to be 0. The other one was 6.23. I don't think you would have got that one. But one of them has to be 0. And since one of them has to be 0, you would say to yourself, either it's the first one that's equal to 0, and that's our first solution, x could be 0, or our second one could be 0. What would make the second one equal to 0? When x is equal to 1. That's why we factor. You were taught that the first time you factor. They might have even told you the name of this property, the zero product property, but it's very powerful, because you're changing something from adding and subtracting to multiplying, and as soon as you're multiplying two things and the answer is 0, one of those two answers has to be 0. And so the same thing here, when we factor this, we can say either, if this whole thing is equal to 0, well then either cos has to be 0, because then it wouldn't matter what this is, then this whole thing would be 0, or if cos of theta was equal to 1, then my second set of brackets would equal 0. Taking this forward is 0 ever on our pie plate as an x coordinate. Is the x coordinate ever 0? Yes. When? At pi over 2 and 3 pi over 2. Is x ever equal to 1? When? At 0 or all the way around at 2 pi. And here you're always going to check your domain. And since it's 0 is less than or equal to theta is less than or equal to 2 pi, you would have both 0 and 2 pi in your answer. I think some of your homework questions have this. If this was the case, then 2 pi wouldn't be part of your answer. Just 0. So you have to be really careful with the domain, because the textbook or multiple choice questions can be take off one little line like that, and then it changes your answer. Yes? Is the which homework in particular? So this question ends up having 4 answers. Ooh. Sine squared minus 3/4 equals 0. If you were solving this question and it said x squared minus 3/4 equals 0, what algebraic things would you do to that to solve for x? You'd add 3/4 to both sides, and then square root both sides. Okay? So whatever techniques you use for solving algebraic things normally, those don't change. So we would, in solving for this, add 3/4 to both sides, square root both sides. Don't forget that plus or minus whenever you square root both sides. And then you have to say, is that on my pie plate? Well, not the way that it looks like right now, but can I simplify that? That simplifies to, well, square root of 3 over, well, square root of 4 is just 2. And is square root of 3 over 2 on our pie plate? Yes. What family for sine? The pi over 3 family. And since it's plus or minus, it's going to be everybody. The whole family. It's like a family gathering here. Look at this. Everybody comes together. All 4 quadrants. Pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. It's because we're getting close to Thanksgiving. Whole family came together. Now, throughout grades 10 and 11, you develop different techniques for factoring. The ones where there's a number in front were always the hardest to factor. So off to the side here, I'm just going to write this with x's. 2x squared minus 3x plus 1 equals 0. If you had to factor this, this one was harder because there was a number in front of the x squared. Now, over time, I'm sure that you learned different techniques. There's like a grouping strategy. There's sometimes different shortcut strategies. And those are all great strategies. But as we move into grade 12, one of the things I want you to be able to do is go directly from this right to the factored answer. And in order to do that, I want to point out some things that always happen. If you have the answer to this, okay? So if we have an answer, I'm going to do a different number. Let's say I have 3x plus 1. Oh, let's do 3x plus 4, x minus 3 as an answer. I want to point out some things. When you multiply this out, you would multiply and distribute, right? And you would do all of these. And what ends up happening is you're going to get a 3x squared. You're going to get a minus 9x and then a plus 4x and then a minus 12. But when you're asked to factor, you're asked to factor 3x squared minus 5x minus 12. right? And that's a hard one to factor because it's much easier to go this way than it is to work backwards and go this way. But there are some things that you can notice that can really help you. The first thing that you can notice is that when you multiply these together, the 3x squared is always what you get when you multiply your first things together. And the 12 is always what you get when you multiply the last things together. So as far as factoring something quickly, the first thing I look at is my first number here and my last number there. If this factors nicely, and we don't know if it does, sometimes it doesn't, and if it doesn't factor nicely, you have to go to your quadratic formula. But if it factors nicely, what's the only thing to give me 2x squared? 1 and 2. 2x and x, right? So because I know that whatever's here is my first one, and my first one is a prime number with a 2.
Sorry for interrupting.
Hello?
Did Cameron Lloyd please come to the office?
Yes.
Thank you.
So I can right away know that if I factor this, this is the only possibility. It has to be 2x and x. There's no other option. What about 1? If I look at my last ones and they multiply to give us that last number, how many options do I have if my last number is 1? It has to be 1 and 1. So I know this has to be 1 and 1. And I'm almost done factoring without even having to do much work. Now I have to decide if the signs in between are both going to be positive or negative. Since my last one is a positive one, can you see that they either both have to be positive or both have to be negative? And this middle number here is always the outside and the inside combined. So they're either both positive or they're both negative, but I'm going to think about my inside and my outside combined. I need a negative 3x. Can you see that the only way that's possible is if they're both negative? So that's going to be a technique that I'm going to keep using throughout the year to factor quickly. If you've used grouping in the past and like to still do that off to the side, okay, but be careful because you have to show all your work mathematically correct. Sometimes people make little algebraic mistakes in their grouping technique. You can come check with me to see if your work is right. But I'm going to be factoring things quickly like this because in grade 12, most of the factoring is easy in that they're not going to have super big numbers at the beginning and the end. And it's usually with those big numbers that the grouping technique is more useful. So I go to this right away. I know that it's going to have to be 2 sine and sine. It's going to have to be 1 and 1, and they're both going to be negative. So if the first one's equal to 0, move the 1 over and divide by 2. Sine theta would be 1/2. If the second one's equal to 0, sine of theta would equal 1. This is on our pi plate. It's part of the pi over 6 family. Because it's positive, quadrant 1 and quadrant 2. Is sine ever equal to 1, the y value? Yes, only at pi over 2.